Okay, we're going to go over a couple of quick things related to transformations. And one of the new concepts we're going to be talking about soon is being able to show congruence by using a translation or a reflection or rotation, any of the rigid transformations to map one shape onto the other. So the idea is if I could take this shape and map it completely onto that shape, that all the points lined up and everything kind of lined up, then I know they're congruent. Well, this looks like a translation. Looks like I'm going up 2 and backwards 4. So if I wanted to try to map this thing on top of that, I could type polygon. So take that table and subtract 4. And with y1, we're going to add 2. And this is actually how this maps. And these are pretty close, but this is not actually congruent. If my blue one here, which I just created with the translation, if these had actually been congruent, one would line up right on top of the other. Now it's possible that this thing is also rotated or something, so I might have to try to do something else to get it to fit, but this actually doesn't fit. It looks pretty close. If you didn't do this kind of transformation, you would never realize that they are slightly off, very slightly off. But that is one way we can show congruence, is if we can do a translation or a reflection or a rotation such that we can map one shape onto the other and kind of show that they line up, then we know they're congruent. So that is something we'll start talking about in the future. What I really want to do right now is, let me throw some of this stuff away, including all that. And I'm actually going to make a new copy of this. Control-Shift-S. Let's duplicate that, and we'll do transformations. Practice more. Okay. Okay, so I am going, in fact, I like using right triangles because I think it's a little easier to see what happens with them. So I'm going to change my triangle here to this. Okay, got a right triangle here. And I'm going to just try some of variations. So I already know how to do translation. I can just add or subtract onto it. So polygon x1 plus 1, y1 minus 3. That's a translation, just adding or subtracting onto x or y. And I could also, take these tables. I could add 1 onto all those, subtract 3 from all those, create the table. That would do the same thing. This is doing it with a rule, but I could also do it with a table. Okay, so I'm just going to try a couple of combinations, and we're going to identify what they are. So the first thing I'm going to try is, oops, got to do it the right way. And we're going to just try negative x, negative x1, y1. Okay. And it seems pretty clear that that is a reflection across the y-axis, going straight up and down there. It's the y-axis. So negative x1, y1. And let's change the color of this so you can, it's a little more exciting. Make it purple. Okay. All right, so that's that one. So you might want to take some notes on these. Let's see. So let's try it the other way around. Can you predict what's going to happen if I make that, if I make that a negative y1? Okay, and so that flips it across the x-axis. So my x-axis is going that way, that flips across there. So that is a reflection across the x-axis. Okay, let's try something else. What if we switch the x and the y? Except I got to get rid of this junk. What's going on? y1, x1. Okay. Can you tell what that is? It is a little bit hard to tell. This is actually a reflection across the line y equals x. You can kind of see that point doesn't move at all. This point moves to here. And so notice you do a right angle straight back to this thing. And this one, once again, it goes diagonally. So straight back, there's a right angle there. Let me see if I can draw that in. That's y equals negative x, I think, plus 6. Okay, you can see from here to there is 2 diagonals. That's a right angle there, and then 2 diagonals further, that's where that point lands. Or actually, I guess this was my starting point. My pre-image is there, and my image is there. It's a little hard to tell. Let me make it a little easier to tell if I was actually going to graph it this way. So let me change this. I think my other one was 3, 1, 3, 0, 5, 1. Okay, that it becomes a little more obvious. Oh yeah, that's the reflection. This thing is looking in the mirror back at this point. One away, diagonal, a diagonal and a half away, diagonal and a half away, and this is 1, 2 diagonals back. So these points are all equal distance from this line, and if I connect both the A and the A prime, if I want to call them that, it'll be at a right angle to that line. Okay, so that is y1, x1. It goes across the line y equals x. Okay, let's make one of those negative. So then that does that. This is a rotation. If I took this axis right here and rotated up, literally turned my computer on its side, this thing is on 3 here, so when I rotate it up, it's 3 there. This is 1 away from 3, so when I rotate it up, this is 1 away from 3. This is 1 away from 5. This is 1 away from 5. It's pointing in this direction. Now it's pointing up. That is a 90-degree rotation because we always rotate in this direction because we've got quadrants 1, 2, 3, and 4. So 90-degree rotation. Now what's interesting, if this was in another quadrant, it would just show up 1 quadrant over. So if I change quadrants on this thing, you will notice, okay, so once again, my original is here in gray. This rotated down 1 quadrant. Okay, so just moved over 1. So that will always rotate to the right by 90 degrees. Okay, so let's try it now. Change that to a negative x. Okay, this is a reflection across the line y equals negative x. So kind of same thing we had before, is these two things are across. Now, if this point had been on the line, it wouldn't have moved. So if like at this point up here, if I made that negative 2, 2, you'll notice at that point doesn't move because it's on the mirror. And if it was on the other side of the mirror, these things would overlap the mirror. So if this was like at negative 2, 3, notice these two things on this side of the mirror show up over here, and this point on this side of the mirror shows up over here. So your line of reflection, if it crosses through whatever shape you have, you'll end up with something like that. Okay, let me go back to where I had this. I think this was 1. And oh, that's as good as anything else. Okay, what haven't we tried yet? I don't think we've tried this one. Okay, this is 90 degrees to the right. So same kind of rotation, but it's going from here back the other way. And then I think the only thing we have not tried yet, if we tried that, we're missing one. And we did just yx, didn't we? Yeah, that's a reflection across the line. I'm definitely missing one, but I think I've spent enough time on this one. See if you can't figure out. I think what we didn't do is 180 degrees, which I don't have my notes in front of me. I don't remember what that was. So that's your homework. Bye.